All right, let's turn over to page 4. The rules here on page 4 are going to follow us for the rest, not only of this unit, but in units 12 and unit 6. These are really important rules. First thing we're going to do is name binary ionic compounds. So the first thing you do is name the cation. The cation is the positive ion, which is usually the metal. Okay, and when I say usually, really almost always the metal. But the cation is the positive ion. The anion is the negative ion, which is almost always the nonmetal. Okay? And really, it's the order it's written in. So Na and F, this is sodium and this is fluorine. So step 1, I name the cation, sodium. And then I name the anion, fluorine, but I change the ending to ide. So instead of fluorine, I would say fluoride. F-L-U-O-R-I-D-E. Okay? Let's jump down here to number 9 and 10. Okay? Name the cation, calcium. Name the anion, phosphorus, but change the ending to ide, phosphide. All right. Name the cation, lithium. Name the anion, bromine, but change the ending to ide, bromide. Okay, so these are the easiest ones to name. You just name the cation, the metal. Name the anion, the nonmetal, and change the ending to ide. There really aren't exceptions to today's homework. Okay? All right. That's what you're doing for all of these. It should be pretty straightforward. These numbers don't change the way we name it. Not for this kind of thing. These little subscripts, these numbers are going to come into effect when we do transition metals on pages 6 and 7 of the homework. Okay, so that's how you name binary ionic compounds. Let's look at 14 and 15 just because you're watching the video tutorial. SR is strontium. Strontium, and instead of sulfur, we make it sulfide. Okay, cation, anion, change it to ide. Cation, potassium, anion, chlorine, change it to ide. Potassium, chloride. Okay, iodine becomes iodide. Oxygen becomes oxide. Those types of things. All right, so they go pretty quick. On page 5, we've got 4 steps, and good gracious, these 4 steps are going to be so helpful if we've got them. The first thing you do is write the symbols, the cation first and then the anion, which is usually the metal and then the nonmetal. Okay, so that's what we did here. We wrote aluminum, Al, and oxygen, O. Step 2 is above each symbol, write the oxidation number. So write the charge that that ion wants to make. So aluminum has 3 valence electrons. As a metal, it wants to lose 3, which will make it positive 3. Oxygen is a nonmetal, so it wants to make a negative anion. Oxygen has 6 valence electrons. It wants to make 2 more. So that's why we did 2 minus 2 like that for its anion. So you write the symbols, write the charges, and then you're going to crisscross. Okay, so I switch it. The 2 comes over here, the 3 goes over there. Then you reduce and erase, step 4. Okay. Let's look at sodium chloride, number 1. The symbol for sodium is Na. The symbol for chlorine is Cl. NaCl. That's step 1. Done. Step 2, write the oxidation number charge. You guys are going to get really good and fast at oxidation numbers, but for now, let's take a look. Sodium's in family 1, which means it has 1 valence electron and it wants to lose it. So that would make me +1 if I get rid of an electron. Chlorine is a halogen, so it's in family 17. It has 7 valence electrons. It really, really, really wants 1 more. If I give it 1 more, it would make a -1. Okay, there's step 2. Write the oxidation number. Step 3 is to crisscross. I'm going to write a 1 and a 1. Now, we would never write 1s. 1s are always invisible, just like you would never say 1x equals 15. You would just say x equals 15. So because they're the same, and because they're both 1s, we get rid of them. And I would just say NaCl. So I have asked my students to show all their work under the name, always, and to write their final answers here. If you are showing your work up here, you have to erase, which means it has to be in pencil. Okay? You can't give me an answer that looks like this on your homework. Let's skip down, because I know we did a lot of these in class, so let's start with 11. Okay? Beryllium. The symbol is Be. Step 1, write the symbols. Fluoride means fluorine. The symbol for fluorine is F. Beryllium is an alkaline earth metal, so it's in family 2. It wants to lose 2 electrons. So getting rid of 2 negatives would make me positive 2. Fluorine is a halogen. Halogens really want to gain 1 more electron. They have 7, they want to get to 8. Negative 1. Alright? So that's step 2. Write the oxidation numbers. Now I crisscross. My 1 comes here, my 2 goes there. That's step 3, crisscross. Step 4 is to reduce and erase. I don't write a 1, it's always invisible. So I'm going to get rid of this and write it as Be, invisible 1, F2. Beryllium wants to get rid of 2 electrons, so it takes 2 fluorines to take them. Each fluorine will take 1 electron, and then they're happy and they can bond with each other. Alright, let's look at magnesium nitride. The symbol for magnesium is Mg. Nitride is nitrogen, so that's N. Magnesium's in family 2, so it wants to make a plus 2 charge. Nitrogen is in family 15, so it has 5 valence electrons. It needs 3 more. Negative 3. So I crisscross them. 2 and 3. Mg, 3, N, 2. Alright, let's see if I can find another good example here. Potassium nitride. Magnesium oxide. Let's do number 10. Magnesium. Mg, oxygen. Oh, oxide is oxygen. Magnesium, we just said, is in family 2. Right here, family 2. So it makes a plus 2 charge. Oxygen is in family 16. So it needs 2 more electrons. It makes a negative 2 charge. When I crisscross, 2 and 2. Now, if we were going to write this in algebra class, we would say 2x equals 2y. Okay? Because it's the same, we can get rid of them. We can reduce it and just say x equals y. So instead of writing 2 and 2, we can reduce 2 and 2 to equal 1 and 1. Magnesium, invisible 1, oxide, invisible 1. If you put, Mg2O2, you'd be wrong. Okay, you have to reduce it. Down here, number 17. Metals are messy. They tend to lose their electrons. Okay? They do not want to get extra electrons. Metals are messy. They throw away their electrons. Losing electrons. Remember, electrons are negative. So losing your negative means you are positive. No. Positive is a cation. So A. Metals will lose electrons and form cations. Which of these elements is most likely to lose electrons in a chemical reaction? Well, metals are messy. They throw away their electrons. So we're asking you which one's going to lose, which one is a metal? Magnesium, chlorine, sulfur, or bromine? Magnesium is the only metal. It wants to lose 2 electrons. Chlorine wants to gain 1. Sulfur wants to gain 2. Bromine wants to gain 1 electron. Alright. What is the oxidation state, number 20, of the magnesium cation? Well, cation means positive, so you can automatically get rid of C and D. Okay, it needs to be positive. And does magnesium want to lose 1 electron or 2 electrons? Magnesium is in family 2, so it wants to get rid of all of its valence electrons, both of them, which means it would be a plus 2. Okay, I'm going to skip 21. Which of the following statements describes alkali elements, alkali metals? Alkali metals have 1 valence electron in family 1. They are going to lose it, which makes it a plus 1 charge. Alright. This is the basis for what we're doing the rest of the unit. If this tutorial was too fast, if you were absent, whatever the case might be, please make sure you're getting in for help. You cannot wait until the end of this unit to get caught up. Alright? Good luck.